Hey guys, this video is about how to find slope using two sets of ordered pairs. Okay, so let's get right into it. This is day 13 and 14 of graphs. I'm just doing one video for finding slope. We'll do finding slope for several days, so if you're struggling at all past day 13 and 14, just go ahead and watch the remainder of this video. Do the practice problems with me, and I think it'll start to click, but you can see me if you still need help. Okay, so slope describes the steepness of a line. We've already learned that. This is at the top of your notes, by the way, on day 13. It is the ratio of the rise, or the vertical change, to the run, or the horizontal change. So it's basically how much you're going up or down as you're going forward. Okay, so like, if you were taking off in an airplane, you would be going in a straight line up while you go forward, and so that would make a diagonal, and that would be your slope. Slope is the same for any 2 points on a straight line because it represents a constant rate of change. Okay, well let's get into how we're going to figure out problems, or how to figure out slope on problems. Okay, so before we do that, let's just take a look at a little diagram here. So we've got this black line right here as a road, and it's probably the straightest piece of road in the Poudre Canyon. And we're going up as we go forward. So if we start here and stop here, we will have traveled 80 feet forward, and we would have gone up for 25 feet. Okay, so my slope, the rate of change, or the way we're going to write that ratio, is we're going to write the rise over the run. Now in this particular problem, the rise is right here. It's 25 feet, and the run, or how far I'm going forward, is 80 feet. Okay, so we would write 25 feet over 80 feet. And if we simplify that, we would simplify it to 5/16, or 0.3125. In this unit, we are not going to divide out the fraction into a decimal, so you don't need to worry about that, but you could express slope that way if you wanted to. All right, let's take a look at another example here. All right, we are building a ramp so that Mrs. Juergens can roller skate in and out of her front door. And for every 6 feet I travel forward, I need to go up 1 foot. Okay, so I'm going to write rise over run. 1 foot over 6 feet, or 1 divided by 6, and so my slope is 1/6. Now think back to when we were talking about scatter plots. We learned that a slope going up from left to right is a positive relationship. A slope going down from left to right as it goes forward is a negative relationship. And you can see right here, as we're going up, that's puff positive, right? You guys remember slope, dude? So that's going up from left to right, so that's going to be positive. And here we have a positive slope. I'll show you what a negative slope looks like in just a second. All right, so when we talk about finding slope, we're talking about how much a line rises as it moves forward or runs. Okay, so we talk about rise over run. So we have a formula to find this, and I'll show it to you in just a second. But before we do that, let's just look at a simple line here. If we were to look at this point right here, and then look ahead to this point, we want to find rise over run. We can just count up 1, 2, 3. That would be the rise. Okay, right there, right? I went up 3, and I went over run 1. That's the run. So my slope is 3 divided by 1, or 3 over 1, which simplifies to 3. So what we're doing is we're finding the rise, so 1, 2, 3, over however many the line goes over or progresses forward. Okay, so we have a formula for this. This is our slope formula. And I know it looks way scarier than just rise over run, but it's really not. All we're doing is we're finding the rise here, which is y2 minus y1, and so that's the change in y, right? And then we're going to put that over the change in x, which will give us the run, okay? So when we do this, what we do is we will decide that one set of ordered, or one set of coordinates is our x2 and our y2, and that the other set of coordinates is our x1 and our y1. And then after we decide that, then we'll fill in our formula and we'll solve it. It's just as easy as that. So let's do one together. Okay, here's my formula. y2 minus y1 over x2 minus x1. Okay, now the first thing I want to do is I'm going to decide which coordinates are going to be my x1 and my y1, and which ones are going to be my x2 and my y2. Okay, now I'm going to go ahead and I'm going to label these ones right here x1, y1, and then I'm going to label these x2, y2. And there's another way we can do this too. We can make a little chart, x, y, and we can label 1, 1, and the other 2. So if I were to do it this way, then I would take this set of coordinates right here, the 0 and the 1, and I would fill it in for this one spot and put my y coordinate in there, and then fill in my x2 and my y2, so 1 and 4. Okay, so then that makes it really easy to see which number goes where in this formula. So if I fill in my numbers, my y2 is going to be 4, and then I say minus y1, which is 1, and my x2 is 1, and I say minus x1, which is 0. And then I get, of course, 3 divided by 1, which is 3. So my slope is 3. All right, let's do another one. Okay, there's my formula. Y2 minus y1 over x2 minus x1. Okay, and I think what I'll do is I'm going to label this down here, my x1 and y1. I'll label this x2, y2. If you like to see it nice and neat in a chart, we can do it like this. And so I'll fill in my x and y right here. And then I've got -3 and 3 right here. And there we go. Okay, and then we'll fill in the numbers in our formula. So y2 is 3, so I put that right here. And then minus y1 is 1, I put that right here. Divided by -3, that's my x2, so I put that right here. Minus 3, my x1, which is right there. Okay, so I've got 3 minus 1, which is going to equal 2 on top, right? And then I have -3 minus 3 down here. So now I've got some negatives and I've got a subtraction problem. So I need a copy plus opposite. So when I say copy plus opposite, remember we keep the first integer, so -3 doesn't change. We change our subtraction to a plus sign, or to addition, and we write the opposite of the second integer. So we get -3 plus -3. So then that gives me 2 divided by -6, and if I simplify that, I get -1/3. Now you might be asking, okay, Mrs. Jurgens, the negative's down here, and then all of a sudden you put it up there. I don't know what to do with that. Well, when you have one negative in a fraction or in a division problem, when you divide a positive by a negative, or conversely, if you divide a negative by a positive, it's going to give you a negative fraction or a negative number, okay? So a positive plus a negative always equals a negative. Another way you can think of a negative is just it's the opposite. And so like if you have a negative sign in there, then that makes the whole thing negative. Now here's something tricky. If you have two negatives, it's really like saying the opposite of the opposite. And so what that gives you is a positive. So one negative just equals a negative, or a negative plus a positive equals a negative. But if you have two of them, it's going to equal a positive. So we'll see what that looks like in just a second. All right, let's do another couple problems here. All right, so there's my formula again, y2 minus y1, x2 minus x1. And I'm going to go ahead and make this one x1 and y1, and I'm going to make this x2 and y2. And then we'll plug in our numbers. Oh, I guess I did that backwards up here. I had it the other way around, which actually, by the way, it doesn't matter. You can decide to do whichever one you want to be x1 and y1 and x2 and y2. You'll get the same answer. You eventually, when you simplify it, you might get something that's got two negatives, whereas in one way and then positive the other way. But remember what I just told you about two negatives, that they're going to be positive. Okay, so I've got 7 minus -2. So I've got a subtraction problem here. So I want to copy plus opposite that, right? So change that into an addition problem. And I'm going to do the same thing on the bottom. Copy, so keep my first integer, then change my subtraction to a plus sign, and then change my negative to a positive. And here you can see too, look at that, two negatives next to each other equals a positive there too, doesn't it? Okay, so my answer is going to be 9/5. Okay, so we're skipping ahead in your notes here, but for the sake of time, I'm going to have to do that. Okay, so if a line is going down, the slope will be negative. We know that, right? Nice, negative. Yay. Okay. And if a line is going up, the slope will be positive. So when you're figuring out these problems and you're finding slope, if you're ending up with, say your line is going this way, but you end up with -3/2 or something like that, somewhere along the line you made a mistake, because you can't have a negative slope and having it be slope up from left to right, okay? Now what happens when you get a slope like this? Look at this line, it's horizontal. Well, every time we have a horizontal line, and I'll prove it to you in just a second, you're going to end up with a slope of 0, okay? So let's go ahead and let's fill in our y2 minus y1 over x2 minus x1. And let's see, I've got, looks like this is my x2 right here, and this is my y2, and this is x1, and this is y1, and I've already filled those in over here. But you can see what I mean in just a second here. So on the top we've got -3 minus -3. I'm going to change those to pluses, but just think about this for a second. If I subtract something, right, I'm taking it away. If I've got -3 here and I'm taking away -3, what I'm going to end up with? I'm going to end up with 0, right? Okay, then I've got -3 minus 2, so I'm going to change that to addition. -3 plus -2 down there. Okay, that's my copy. Plus, and then I write the opposite integer. And I'm going to get -0/5. And if I simplify that, 0 divided by any number, of course, is 0. So what is always going to happen is you are always going to get a slope of 0 for a horizontal line, okay? And that's because, if we have rise over run, this line is not increasing in rise at all, is it, as it runs? It's just staying flat. Okay, now what about a vertical line? A vertical line is going to be a different situation. Let's fill in some numbers here. We've got y2 minus y1 over x2 minus x1. And this is my x1, y1. Oh, actually, I have that backwards, don't I? This is x2, and this is y2, just the way that I have it set up in my PowerPoint here, and x1 and y1. So I've got -2 minus 3 over 2 minus 2, okay? So obviously this is going to give me, -5 over 0. You cannot divide any number ever by 0. And I can prove that to you. There's a reason for it. Basically, you can't divide something up by groups of nothing. That's not possible. And you can't multiply. Like if we look at this problem, and since division is the inverse of multiplication, I can't multiply any number by 0 and get 5, can I? Or by 0 and get -5. That's just not possible. And so whenever you divide a number by 0, you have a slope like this where the number's on top of 0. We're going to call that undefined, okay? You will not say that a vertical line, has a slope of 0. That's not correct. The slope is undefined, and that's how you will answer that type of problem. Okay, hopefully this helped a little bit, and let me know if you have any more questions. Thanks.